Let's get started, guys. So as all of you know, we have started the discussion of ACI, which stands for Application Centric Infrastructure. So it was weekend, Saturday and Sunday, right? So let's just get the quick revision of our previous session and then we'll move further. So in the previous session, here, think, yes. So in the last class, we have discussed about VXLAN configuration. After VXLAN configuration, we have seen what is SDN, software defined networking. And in the defined networking, we have discussed about the importance of the network controllers. But before that, we have seen what is the data plane, control plane, and management plane. Why do we need the network controllers, right? After that, we have seen different solutions. We have local area network solutions. For local area, we have software defined access. Likewise, we have SDN solutions for wide area network. Then we have data center network. So in wide area network, we have Cisco Viptela SD-WAN, which is now known as Cisco Catalyst SD-WAN, known as Catalyst SD-WAN. After that, we have data center network, and in data center network, we have ACI, application centric infrastructure. Then we have discussed that why we gave it this name, application centric infrastructure, because now our focus is to enhance the experience of applications, application installment and all. So our focus is on the application now. We don't want to focus on the underlay and all. That's why the underlay is completely automated in our ACI environment. We are automatically configuring IS in the underlay. We are automatically configuring IS in the underlay. All right. Then basic infrastructure, that's what we are going to cover in the upcoming classes. This was the overview. And then how ACI is going to help us in data center networks. All right. Just a second, guys. I'm getting the benefits of this ACI solution. Now let's get started, guys. I hope all of you guys have revised the previous class. Hello. Am I audible? Hello. Yeah, so I'm sure that you guys have revised the previous class, right? All right. Okay, then let's get started with the ACI part, application centric infrastructure. So in this application centric infrastructure solution, we have two main components. First of all, first we have the Nexus switches, right? And then we have the Cisco APIC, which is application policy infrastructure controller. And when we talk about Nexus switches, the major series we are using here is 9300 series, and we are using 9500 series of switches. We are using 9300 series of switches and we are using 9500 series of switches in our ACI environment. In the ACI environment. And we have already discussed about the architecture that ACI, application centric infrastructure, is using spine and leaf architecture. So in this spine and leaf architecture, we have two layer of switches. One layer of switches is known as the spine layer, which act as the distribution layer. So in traditional network, we have distribution layer. Similarly, we have spine layer in this two-tier architecture. Then we have leaf 1 and leaf 2. Leaf 1 and leaf 2. Now the leaf switches are connected to the spine switches are connected to the leaf switches. But leaf to leaf and spine to spine connectivity is not allowed. Then the controller known as APIC, Application Policy Infrastructure Controller. So this APIC is connected to leaf switches. The APIC is connected to the leaf switches. This is the connectivity we have in ACI, and this is known as ACI fabric. Now guys, we'll start talking about each and every component individually. Now we're going to start with the each and every component individually. We'll discuss about Cisco APIC. We'll talk about the Nexus switches and the hardware. Okay. One more thing that you remember, we have two types of operating system on Nexus switches. Yes guys, please tell me the type of operating system on Nexus switches. How many types of operating system do we have? Very good. So we have two types of operating system on Nexus switches. First is known as the NX OS and second is known as the ACI OS. So here we have two options. When you buy a brand new switch, Nexus switch, at that time you have always a choice to make a decision. You can ask them to give you ACI OS switches or you can ask them to give you NX OS switches. But if you want to upgrade or if you want to migrate your existing Nexus environment to ACI, then first of all you have to download the image from Cisco official website, and then you have to upload it to the NX Nexus switches. And you remember that on Nexus switches we always set the bootable image. We always set the bootable image. So you have to change the ACI image to the bootable image. So next time whenever your Nexus switch will boot, it will always boot from the ACI OS operating system, and after that you can onboard it on Nexus, this ACI, or you can say APIC infrastructure. All right. Now the topology could be like this also. In this topology, notice that the external appliances. So this is the spine which act as the backbone. Leaf switches is providing connectivity to the servers. Now you can have a physical server which is running an operating system, or we have the servers. Inside this server we have installed virtual machines. You might see that okay, a server is connected with leaf switches, but guys, in most of the time in data center network, when you connect a server with the leaf switch, the server is not just a normal server. In this server, first of all, we install a hypervisor, a software hypervisor, and then this hypervisor will create a vSwitch inside this server, and then we have the virtual machines. And this server has the physical interfaces. They are connected to the leaf switch. They can be connected to different leaf switches also. Now this time these are the machines who is connected to the leaf switches, but they are not directly connected. So that's why in case of ACI environment we have two types of appliances. We have physical endpoint and we have virtual endpoints. So we can have physical endpoints or we can have the virtual endpoints here. We can have the physical endpoints and the virtual endpoints. So in this case, these virtual machines are the virtual endpoints in our network. They are the virtual endpoints in our network. But you might have a appliance which is directly connected, a standalone server, which will is also going to act as the endpoint. So we have always two types of endpoint here. So that's why this is the visual representation here. Then you notice that in our topology, we have just one APIC, but this thing is known as APIC cluster. So for production environment, it is always recommended to deploy a cluster of APIC. It is always recommended to deploy a cluster of APIC, and minimum requirement is 3. So when you want to deploy a cluster of APIC, the minimum requirement is 3 APIC in a cluster. You can have 5, you can have 7, max to max you can go up to 9 APIC controller in just one cluster. Then external WAN campus, wide area network, or rest of the network, which is non-ACI fabric. So this is non-ACI network, this is ACI network. So we have ACI to non-ACI connectivity, and for that reason I was already giving you an idea, right? The day when we were talking about the content which we're going to cover here. So we have also a part known as external connectivity. So this is known as the external connectivity. This is your ACI fabric. And this part is not, this side of the network is not part of the ACI. That's why we are going to call it non-ACI environment. That's why we are going to call it non-ACI environment here. This kind of topology we have in data center ACI, guys. It could be anything which is not managed by the Cisco APIC. It could be any type of network. It can be internet connectivity, your normal catalyst switches, your storage area network, anything which is not managed by Cisco APIC, known as non-ACI fabric. Okay. Hello. Okay. Sorry, non-ACI what? They are known as border leaf. Yes, true. There are types of leaf switches. Okay, and in this case, it is known as the border leaf. It is known as the border leaf. So you have border leaf, you have service leaf, you have transit leaf, you also have storage leaf. So in this leaf you have type of leaf switches, which depends, which actually the switch is identical, but it differentiate on the basis of, sorry, yeah, actually it defines that where is this leaf is connected, or what kind of connectivity is providing. So we have border leaf, then we have services leaf. Let's say you have connected a firewall or a load balancer. Those appliances are known as service appliances. So if it is connected to the leaf, that switch will be known as service leaf. Then you have transit leaf. and we also have storage leaf. So we have types of leaf switches. See, again, it's just an access switch. Either it is a border leaf or not. What we are doing here, in this case, let's see this switch. This is a normal leaf switch. It is not connecting to you any different type of network. It is just providing connectivity to the endpoints. But in this case, this leaf can be known as border leaf. Why I am calling it border leaf? Because this leaf switch is providing connectivity to such a network which is not part of my ACI. These routers are not part of my ACI network. This is also a border leaf. So actually it is just an access switch and also leaf switch. The role is also leaf, but we are just trying to differentiate on the basis of the type of connectivity it is offering at the moment. Okay. Service leaf means that when you have connected a service appliance to the leaf switch, let's say you have connected a firewall or you have connected a load balancer. So any leaf switch which is providing connectivity to such appliances will be known as service leaf. Okay. As it name suggests, it is act as a transit between two ACI topologies to provide connectivity across multiple geographical locations. So this is also known as stressed fabric. And then you have the storage leaf, which provides connectivity to the storage area network. That leaf is known as storage leaf. Okay. All right. Then guys, we were talking about the Nexus switches here. So in ACI environment, we are going to use the Nexus switches in ACI OS mode. And our Nexus ACI solution is based on Nexus 9000 series switches. So 9000 series is the parent switch. In this 9000 series, we have two major family of switches known as 9300 series and 9500 series. So in 9300 you simply refer it as 93XX means, or here you have 95XX. Access means that these are the variables. They might define the number of interfaces or total bandwidth. XX is also representing, like let's say you have a chassis switch 9508, 9504. So basically they are the specific platforms we have in the Nexus switches. These are the specific platforms we have in Nexus switches. Those switches are known as 9508, 9504, 9516. So it keeps changing on the basis of the model of the Nexus switch. It keeps changing on the basis of the model of the Nexus switch. But first we have to understand few fundamental things about these Nexus switches. I think I've already gave you this introduction in the Nexus class also, that whenever we are going to buy a Nexus switch, we always see a naming conventions, different names, and then we have to choose a platform. Let's say if we visit cisco.com website here, the official website of Cisco, we go to product and services, networking, data center and cloud networking. Here we see the switches, 3000, 9200, 9300. Then 9500 series switches, fixed switches and modular switches. In case of fixed switches, let's see, we have 9300 series. So in 9300 series, you can say I want to explore this. Compare all models. Now you notice that we have 9300 series at the top. In 9300, you have different switches. You have different switches. So first of all, in the Nexus switches, we have not on the basis of series, but we have switches known as fixed switches, fixed Nexus switches, and we have modular Nexus switches. Who will tell me the difference, guys? Who will tell me the difference between modular and fixed Nexus switches? Any guesses? Sorry? Okay. So, yeah, as its name suggests, as its name suggests, fixed switches have a non-removable chassis, all switch ports fans, power supplies and other hardware components are present within a single unit. Here we have the examples. Nexus 9300 series. So Nexus 9300 series switches are the fixed Nexus switches, and they are just taking very small space inside the rack also. They're taking very small space inside the rack also. So if you notice, here we have these switches. This is what it is, like the number of interfaces will remain as it is, no changes in that. So in this case, if we notice, so this is my Nexus 9300 series switch, and that's why we call it fixed. It is what it is, no changes, nothing can be removed or added. So you notice that the number of interfaces 1 2 3 4 5 6 7 8, so 16 plus 16 plus 16, so we have 48 plus 6 switch port. So in this case we have total how many interfaces, guys? 54 switch ports, right? Okay, now I'm damn sure, I'm very sure that all of you guys know why do we have these special interfaces. What is the role of these interfaces? I hope all of you guys already knew this. What is the motive of these interfaces here? Okay, actually, yeah. So it is right. See, when we talk about the topology, if we look at the architecture of us, two-tier architecture or three-tier architecture, so we are using spine and leaf architecture here. So in this spine and leaf architecture, you notice the bandwidth of this interface, let's say, is dedicated for this server, but bandwidth of this interface is not dedicated for any specific server. The interface which is connected between leaf and spine switches, the bandwidth of this link is shared. The bandwidth of this link is shared. So now the problem is, if the downlink which is connected towards the endpoint and this is known as the uplink which is connected towards the spine switches, if they are of the same bandwidth, then we always have the possibilities of congestion, guys. If you notice that when you go inside a sector, right, or when you see the road outside of your house, and if you compare it to a highway, so you see a difference, because the number of vehicles on the highway is way higher, right, than compared to your locality. So that's why we have to build highways so that we can accommodate more number of vehicles. Similarly here, the downlink is okay, which is having a dedicated bandwidth for a user, but what about the common link? So the bandwidth is shared, and this link is also known as uplink. So in this scenario, when you see spatial interfaces, here, so these interfaces are designed to provide connectivity to whom? To the end user. The servers will be connected to these switch ports, and this switch port will be connected to, let's say, your spine switch. This interface might be going to another spine, or there's a possibility that I'm using multiple interfaces with one spine. Due to the bandwidth requirements, I can add more number of interfaces also, and the bandwidth of these interfaces is always going to higher than these interfaces. So these interfaces are known as uplinks. Make sense now? Hello? Okay. But this is a fixed module switch or fixed nexus switches. We can't make changes in this. Then when it comes to modular chassis, modular nexus switches. In modular nexus switches, we have the switches who has modular switches consist of multiple line cards, fabric modules, supervisor engines, fan trays, and system controllers. Also known as chassis switches. The hardware components can be added, removed, replaced, or upgraded independently. we'll come to this part. We'll see that how does this switches look like, right? And for example, we have Nexus 9500 series. Nexus 9500 series of switches we have in this modular. Okay, here Cisco Data Center modular switches 9500 copy image and paste it here. So they are the again fixed switches, but these are the modular switches. In this case, this is known as a chassis, and this is 9504. This is 9508, and this is 9516. 9516. 9504. It means that it has 4 line cards. By the way, guys, they are the switches, but here inside a chassis we call them line cards. We'll discuss about each and every component, but this is line card 1, 2, 3, 4. In this case, it has total how many line cards? 8 line cards. How many line cards it has? 8 line cards. 1, 2, 3, 4, 5, 6, 7, 8. And this particular switch has 16 line cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it has 16 line cards. Now you'll say, okay, do we need to add all of the line cards in once? No. As you need them, you can keep adding those line cards. If you have 9516, you can use it with 4 line cards also, 5 line cards, 6 line cards. So you can keep adding more and more line cards as per your requirement. As per your requirement, you can keep adding more and more line cards here. But the benefit is the management. The entire switch is managed as just one switch. The entire chassis is managed as just one switch. Now, the fixed switches, or not fixed switches, but I would say the Nexus 9000 series switches. They're used as more as a spine switch, leaf switches. They're the best choice for leaf. Nexus 9300 series switches are best for the role of leaf switches. Nexus 9500 series, they are more powerful comparatively, right? But there is no such scenarios that okay, only Nexus 9500 can be used as spine only. No, you can use them as leaf also. Nexus 500 series switches can be used as leaf and spine. It totally depends on the size of the network. It totally depends on the size of the network, but you can use them for spine role as well as you can use them for leaf role. We are not talking about individual switches for the moment. We have just discussed that what is the fixed nexus switches and what is the modular nexus switches. We'll come to the specifications, guys. We'll talk about them, that what are the specifications of each and every switch. But there are some people, I think, who are new to the class. By the way, we have already discussed about this thing. But here, whenever we check the nexus switches, whenever you check any platform, you always see their names. Sometimes they are very confusing. Let's say you see here name Nexus 93120TX, 93108TCEX, 9348GCFXP. How does this name is here? How does we get this name? Remember, we have discussed about this thing, guys. Hello. Audible, guys. Hello. Okay, guys. Please give a response. Thank you. So now taxonomy for Nexus 9K part numbers. So if you are new to the class, let's just get a quick revision. Whenever we see a name of an access switch, it's not just a random name or it's not a coincidence, right? It has a meaning, it holds a meaning. So that's why whenever we see an access switch name, let's say Nexus 9K, it means 9000 series. A represent what? It represent a platform type. And 9KC means chassis. If it is a chassis, otherwise it will be a normal name. Then line card for modular chassis. BB, platform hardware. It can be 9200, 9300, 9400, 9600, 9700. So if you pay attention here, the Nexus 9200 series switches, they can run in NXOS mode only. But Nexus 93, it means it can run as ACI, NXOS or ACI, 94, 96. Then we have 9700 series. But 95 is missing here. We have 95 also. Why? Aggregate port bandwidth. So now it could be, it holds two things, guys. Always remember this. If you see here, yeah, you have this name. You have this name here, 93120TX, right? And then we have one more switch with the name Nexus 9348 GCFX3. So in this case, both of these switches belongs to Nexus 9300 series. Nexus 9300 series. But there's a difference. You see 93120, 9348. 9348. So if all the interfaces are of same speed on all ports, total number of ports, and if there are multiple port speeds, total bandwidth in tens of 1 Gbps. It means that when you look at this 9348, it means that all of the interfaces are having the same bandwidth. All of the interfaces are having the same bandwidth. 48 interfaces of the same. But when you look at this 93120, you have 96 ports which can go up to 10 Gbps. Maximum they can go up to 10 Gbps. And then you have 6 interfaces. Maximum they can go up to 40 Gbps. So if we do this math, 96 into maximum they can go up to 10. So they can give you 960 Gbps of throughput plus 40 into 6. Sorry. 6 multiplied by 10, which is 960, right? So now what we will do, 60 into 4, which is 240. So you can add 960 plus 240. We are getting a number of 1200. It means that this particular switch, it can give us total throughput of 1200 Gbps. But you can't write it like this 931200TX. So that's why they kept as multiple of 10 Gbps, tens of Gbps. That's why instead of 1200 they are using 93120. It means this time 120 is not representing the number of interfaces. This thing is representing the total bandwidth. Make sense, guys? Yes. Can you just go out of? Okay. Yes. It's the blade set because in blade we have this chassis. Yeah. The line card is also used inside this modular switches. In normal switches, when they have the fixed switches, you'll not see any keyword like C or X. You'll only see these keywords in case of a chassis. Yeah. This whole thing is known as chassis, okay? But inside this, you are adding these switches, but they are not known as switches in this case. They are called as line cards. To represent the line cards, you will see the X keyword, and to represent the entire chassis, you will see the C keyword, okay? Then here you see like G, P, T, Y, Q, L, C, D. Yes. Four line cards would be there, not chassis, four line cards. No, one means one line card, but the entire thing is known as a chassis. Yeah. Yes. Then we have the types of interfaces or the bandwidth. So here you see that we have T, means it can go up to 10 Gbps, right? But it also has 40 Gbps interface also, but they have removed Q here. It must be having the Q, TQX. Then here we have GC. G means 100 Mbps, but we also have variants. It means that in this Nexus switches, we can have the variants who can support up to 100 Gbps also. One interface could be go up to 1 Gbps. If we look at this table here, 1 Gbps port. So it has two special interfaces. The uplinks, each of 100 Gbps to connect to the uplink switches, or you can say connect to the spine switches, because you know you need high switch or high bandwidth interfaces to connect between the switches. So this name always holds a meaning. This name always holds a meaning. It's not just a random name. Not just a random name. So you must know that, okay, whenever we choose a switch, it always has a meaning, and the name is self-explanatory. Means you can just get the idea that what is this switch having, or what are the capabilities of this particular switch. What are the capabilities of this particular switch? What are the capabilities of this particular switch we have here? All right. In which we have only fixed one, yes. Yes. Fixed switches, modular switches. Then we have the naming convention here. After this, in our ACI environment, we have the individual switches, right? Then if we talk about modular switches, because if you look at the fixed switches, in fixed switches, what kind of components we have? In fixed switches, we don't have any specific components. You have the components like fan. Inside this, we can have NVRAM. Right? You can have RAM, number of interfaces. So fixed switches components, we have very few components in the fixed switches, because we know, or we are aware of this. You have the Ethernet port. You have the management port. Which is known as management 0. Then you have the console port. USB port is also available, guys. In most of the Nexus switches nowadays you will see USB ports. You will see the USB ports. These are the type of interfaces you will see. One more thing you remember, right? In the Nexus switches, guys, if you talk about catalyst switches, if you talk about catalyst switches, if you have a switch and this switch has physical interfaces with a bandwidth of 100 Mbps, so whenever you're going to configure the interface, you will see number like F0/1. If you have the switches and the switch ports having 1 Gbps of bandwidth, so if you want to configure the interface, you have to say gigabit Ethernet 0/1. But in case of Nexus switches, we had this enhancement, or you can say simplicity. Whenever you configure an access switch, the type of interface is always going to be Ethernet. Ethernet 0/1, Ethernet 0/2, Ethernet 0/3, irrespective of the bandwidth. Either it would be having 1 Gbps, 10 Gbps, 100 Gbps. But whenever you're going to configure it, the number is no, sorry, the type is always going to Ethernet. There's no change. Like fast Ethernet or gigabit Ethernet, you don't need to mention such things in Nexus switches. Management port, yes, dedicated management port is must for out of band access. Console port for the first time access, and then we have the USB port. For what reasons we use the USB port, guys? Any guesses? Hello? I'm audible. Hello. Okay. So what is the use of this USB port, guys? Okay, I think I'm not audible. USB port is used for image upgrades or configuration backup, guys. You can simply plug in a USB drive in your Nexus switches. You can upgrade the switches using this USB drive, or you can take the configuration backup to this USB drive. Okay, but just confirm me one thing: am I audible? Right? Otherwise, I'm just speaking continuously and you guys are not hearing me. I'm audible to you, everyone? To everyone, right? Thank you, guys. Okay. Okay, guys. Okay, this is what I want to confirm. Otherwise, I would be speaking continuously, and then you guys might be on mute or something like you. I'm not audible to everyone. That's why. So we have these ports. Then we have rest of the components like you have fan modules, the CPU, power supply units, RAM, read access memory, TCAM, storage, then all these things we have in normal switches. Yeah, there will be flash now. They have combined it. And now we don't have separate NVRAM, we have a flash memory here, okay? Yeah. Then when we talk about this chassis switches, in chassis switches we have the image is not clear enough. Okay, but I hope it's visible, right? Then let's check the detail of this Nexus 9504. We have 9504, then we have 9508. And then we have 9516. Then we'll talk about these components, guys. Just a sec. So later on, whenever you guys will be making notes, it will be helpful to you also. So inside this 9500 series switches, we have these components, the building blocks of this 9500 series chassis. Okay, we have this 9500 chassis. So you see the components here. One, so you see the components like this. You see the components here. Power supply units, fan trays, system controller, supervisor module, and then you have the line cards. Then you have the line cards. First of all, power supply units. This one. So in this power supply unit, at this moment, if you notice, we have all these slots available, but then we have installed 1, 2, 3, and 4 power supply units only. So what does this power supply unit do? Provide power to all chassis components, right? And the power supply units are available in both formats, guys, like active current or direct, alternate current or direct current, AC or DC versions are supported. Then the power supply units are also hot swappable, means that in running device you can just add or remove these power supply units. Then you have the fan trays. As its name suggests, fan trays. What does this fans do here? As we know that the fan trays are responsible for maintaining the airflow through the chassis. They are the air flow. Then in case of this chassis, guys, when you use this fans, there are two types of air flows. Okay, you have front to back or back to front. We have two types of air flows inside this fence. If you have a blue handle on the fan trays, it means that it has front to back airflow. And if the handle is red, it means there is a back to front airflow. But it doesn't make any difference. The airflow should be there, okay, just to cool down the whole system. But these fan are not enough, because you know that whenever you look at the data center environment or the Nexus switches, they are placed inside a air conditioner room. And it's not just a normal air conditioner room, guys. You see a lot of air conditioners in that room. It's very cool inside. So that's why we have this fan here to cool down the whole system. Sorry, means what? Okay. So then we have system controller. This fan trace is also hot swappable, guys. In the running appliance, you can add or remove this fan trace. At this moment, you notice that 1, 2, 3, 4, 5, 6. But the number of this depends on the chassis also. So if you look at this 9504, you have up to 4 power splice. And how many fan trays? Up to 3 fan trays. But on the other hand, if you see 9508, you can have up to 8 power splice. And how many fan trays? 3 fan trays. Then 9516, you can have up to 10 power splice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And up to 3 fan trays. Up to 3 fan trays. Then here we have a system controller and supervisor module. What does this system controller is doing? This system controller is responsible for handling the power distribution, the fan speed, temperature, right? And it also manages the out of band management connections, environmental sensors. So that's why you will be able to see the temperature of the nexus switch, the operating temperature of the nexus switch, because now we can't give all these things to the CPU to manage. That's why we have added this extra component here to take care of this kind of stuff. The system controller here is responsible for such things. Manage fan speed, temperature also. Okay. Manage out of band management, etc. All these things will be taken care by the system controller, or the CPU does not need to involve in all these activities. Sorry, come again. Yes. So in data center network, we always have this, I forgot the name, guys, but we call it. We were having this discussion earlier also. Uh, there's a dedicated box actually. Remember what we call it, guys? We have discussed about it, and I almost forgot the name. UPS. Yeah, UPS. Uninterrupted power supply. So in data center network, the power supply is not like going directly to the devices from the main power supply. No, we have always a UPS in between, and that UPS will take care of the power supplies. The UPS will take care of the power supplies. And even you know that in highly critical network, we might be using two UPS, uninterrupted power supply, uninterrupted power supply. And if I'm giving multiple source of power to this switch, I'll make sure that I'm using two different UPS connections. In this case, even if the entire UPS system goes down, still my Nexus switch will be in running state. Still my Nexus switch will be in running state. Okay. After that, so you can see here we have system controller. In 90504 you have two system controllers, because two system controllers are enough. Again you have two system controllers and you have two system controllers. They're enough guys of system controllers. Then similar to a system controller, you have one more component which is known as supervisor module. So what does this supervisor module is doing here? It is offloading the you can say the responsibilities of our CPU, or you can say that it manages the control plane, also known as the brain of the switch, because it is taking care of the control plane. It is taking care of the control plane. You have two supervisor module for redundancy. So we're going to have two supervisor modules for redundancy in our Nexus switches. So it will handle the control plane policing, system management, configuration synchronization, the monitoring and all, as well as if you want to upgrade the software, all these things will be taken care by this supervisor module here, the supervisor module. And we have always two supervisor modules. So supervisor module is in the front side. This is the supervisor module, and in the back side you will see the system controllers. You will see the system controllers. After this we have the line cards, which are installed inside this chassis. The line cards are installed in this chassis. So if you talk about this 9516, it has 16 line cards. 1, 2, 3 like this. If you count them, there will be 16 line cards. In 9508, you have 8 line cards. That's why we got this name. That's why we got this name 9508. So it means 8 line cards. 9504, it means 4 line cards. It means 4 line cards. It has 4 line cards. Yes, please. It depends, because the 10 Gbps also support the Ethernet interfaces. So it depends. If you look at this chassis, inside this, the first one, you have all the RJ45. So you don't need a SFP in this case. but in these bottom three you see the SFPs are required. So it totally depends on the line card. Totally depends on the line card. See, the it depends on the port. So according to the port you add the SFP. So first, sorry, yeah, using the ports. See, the end user or the storage appliances will not connect to the spine switches directly. They'll connect to the leaf switches. Okay. Then if we look at this 9516, the weight of this switch is, guys, see, 87 kg. For 9508, the weight is 68 kg. And for this one, the total weight is 38 kg. This much space they are going to take in the rack. 7 rack units, 13 rack units, 21 rack units. Then supervisor, system controller, fabric modules. These are the specifications of the fan trays, power supply units. Okay, then if we go to the main page, they can also have these number of interfaces, 2304 number of interfaces. That is also a possibility. All right, guys. So these are the building blocks of the switches which we are going to use in our ACI environment. We're gonna have the leaf switches, spine switches. There are two types of switches: fixed nexus switches and modular nexus switches. Okay, guys. Till now, if you guys have any question, please feel free to ask. Otherwise, we will wrap up here today. Okay. I think that is enough